Hey everyone, and welcome. Today we're diving into a really important topic for CBSE Class 10 Mathematics. We're in Chapter 3, looking at pairs of linear equations in two variables. And specifically, we are going to master a super powerful tool, the algebraic solution using the substitution method. So let's get right into it.
We're from the Roy's Academy faculty team. If you're looking for more video explainers just like this one, you can connect with us at Roy's Academy. The number is 8910890311. I'll repeat that, it's 8910890311. We also have another number, 8910600503. Again, that's 8910600503.
All right, so here's our game plan for today. First up, we'll talk about why we even need an algebraic method in the first place. Then we'll break down the substitution method into 3 super simple steps. After that, we'll put it to the test on a standard problem and then a word problem. And finally, we'll look at some of those weird special cases you might run into.
So let's kick things off with a really important question. If we can already solve these equations by drawing graphs, why on earth do we need to bother with another method?
And that's a totally fair question, right? Graphing feels intuitive. You draw one line, you draw the other, and you just see where they cross. Simple. But what happens when that intersection point isn't a nice, clean, whole number?
Well, this is exactly where graphing kind of falls apart. Just imagine trying to eyeball a point like the square root of 3 or a messy fraction like 4/13 on a hand-drawn graph. It's not just hard, it's pretty much impossible to get the exact answer. We need a method that gives us perfect precision every single time. And that, my friends, is where algebra comes in to save the day.
Okay, so let's officially meet our new best friend, the substitution method. This is such a slick and powerful way to get those precise answers we're looking for.
You know, the best part about this method is that the name tells you exactly what to do. The whole idea is to take one of the equations, express one variable in terms of the other, and then you substitute that into the second equation. It's a really clever trick that turns a complicated 2-variable problem into a simple 1-variable problem, which, hey, we already know how to solve.
So it all boils down to this simple 3-step process. Let's make this our mantra, okay? Step 1, isolate a variable. Step 2, substitute and solve. Step 3, find the other variable. Isolate, substitute, solve. Easy as that. All right, enough with the theory. The best way to really understand this stuff is to just see it in action. So let's roll up our sleeves and walk through a classic example together.
Here we go. Here are our two equations. We've got 7x minus 15y equals 2, and we've got x plus 2y equals 3. Our mission, should we choose to accept it, is to find the one single pair of x and y values that makes both of these things true.
Okay, step 1, isolate. We need to look at both equations and be a little bit strategic. Which variable is going to be the easiest to get all by itself? Well, look at equation 2. That x is just sitting there with no number in front of it. That makes it the perfect target. A little bit of rearranging, and boom, x equals 3 minus 2y.
Now for the big move. Step 2, substitute. We're going to take that expression we just found for x, that 3 minus 2y, and plug it right into the other equation. So where equation 1 had an x, we now write 3 minus 2y. And check it out. We've just created a new equation that only has one variable, y. That's something we can totally solve.
And now we just do the math. We distribute the 7, which gives us 21 minus 14y. Then we combine our y terms together. So minus 14y and minus 15y gives us a big minus 29y. A little tidying up, and we get negative 29y equals negative 19. One quick division, and we have our answer. Y equals 19 over 29. See? That's the kind of exact answer you would never, ever find by graphing. We are so close. We're on the last step. Step 3, find the other variable. We just take our shiny new value for y and plug it back into that easy equation we made back in step 1. A little bit of work with fractions, and we find our final answer for x, 49 over 29. And there we have it, our unique solution. Okay, that's all well and good for a bunch of x's and y's, but where does this actually show up in the real world? Let's tackle a word problem to see how this is actually a practical skill. A classic age problem. Now remember, with any word problem, the absolute first step is always to translate the sentences into math. So let's use S for Aftab's age and T for his daughter's age. Based on the clues in the problem, we can build these two linear equations. Now that we have the equations, guess what? We just run our 3-step playbook all over again. Isolate, substitute, solve. Looking at equation 2, getting s by itself is clearly the easiest move. So s equals 3t plus 6. Next up, we substitute that entire expression for s right into the first equation. And just like that, we're back to an equation with just one variable, t.
We just solve for t, and we get 12. So the daughter is 12 years old. To find Aftab's age, we plug that 12 back into our simple equation for s, and we get that s equals 42. So Aftab is 42. See how we took a confusing story and turned it into a clear, solvable problem? That's the power of this method.
Okay, now for the really fun stuff. What happens when something unexpected occurs? What if you're halfway through solving and suddenly all your variables just, poof, vanish? Don't panic. It's not a mistake. It's actually a clue.
And that really is the key thing to remember. When the variables all cancel out, you need to look at the statement that's left behind. Whether that statement is true or false, it tells you everything you need to know about the relationship between those two lines.
So here are the two special cases you'll run into. On the one hand, if your variables disappear and you're left with a statement that's always true, like 18 equals 18, well, yeah, of course it does. This means your two original equations were really just the same line in disguise, so they have infinite solutions. On the other hand, what if you did a statement that's just plain false, like -4 equals 0? That's impossible. This is your clue that the lines are parallel and will never, ever cross. There is no solution.
So, let's just sum it all up. When you solve any pair of linear equations, you are always going to land in one of these three camps. You'll either find one unique solution, you'll discover there are infinitely many solutions, or you'll find out there is no solution at all. The algebra will always lead you to the right answer.
And that pretty much covers it. You now have an incredibly powerful algebraic tool in your toolkit. So, the real question is, now that you can solve these, what other algebraic puzzles are you going to go out and tackle?
This was an initiative from Roy's Academy faculty team. For more video explainers like this one, please feel free to connect with Roy's Academy. Our number is 8910-890-311. Repeating that one more time, 8910-890-311. Our other number is 8910-600-503. And again, that's 8910-600-503. Thanks for watching.